Okay, hold on. I think there was a problem with the speaker. I'll repeat from the beginning. So we are talking about Chapter 2, organizing data. When we say organizing data, we are going to look at two different types, the graphical summaries and the numerical summary. So graphical summary is where we are going to use the numbers, the pictorial ways to represent or summarize your data. When we say graphical summaries, it depends on the type of the variable you use. Okay. So variables, we already know they can be qualitative or quantitative. Qualitative is categorical and quantitative is numerical. So the numerical variable can be further divided into discrete or continuous. Discrete is where you have whole numbers, and continuous is where you can have all the values within an interval. So the fractions, decimals, everything. Okay. Say for example, discrete is where you have number of students in a class. And the continuous is where you have like the temperature, height, weight, rainfall, where you can have decimal values like 23.6 degrees Celsius, likewise. Okay. Now, depending on the type of the variable you have, the summaries that you are going to use, it can be graphical or numerical. There are different methods that you have to go on with. For qualitative variables, you have a separate set of graphs. For numerical variables, you have separate set of graphs. You can't mix them up. And the numerical summaries, again, for qualitative data, you have a different set of techniques. For quantitative, another different set of techniques. So to start the first section, we are going to look at the graphical summaries you can use with both qualitative and quantitative data separately. Okay. Now, before we move on to these graphical summaries, why do you think it is good to represent your data in graphs or in a pictorial way? What is the reason of using graphs to represent your data? Any advantage on using graphs?
Easy to summarize it.
It is easy to summarize. Actually, it is easy. When you look at a picture, it is very easy to get the information. Very quickly, you can get the information. Okay. So you look at an example and see. Right. So let's start with the first one, the categorical or qualitative data. Here's a small example. In this example, you can see the political party affiliation of the students in a certain course. Okay, so you see three different political parties. D for Democratic, this is in USA. R for Republican, and O for other. Okay, the two main parties and other parties together. Now, if you look at this set of letters, it is just a collection of letters, D's and R's and O's jumbled up here and there. By looking at this set of letters, it is very hard to figure out whether D's are the most appearing letter or whether R or the O. It's very hard to figure it out in a glance, right? Now, if you want to find it, you have to count it and note it down. Then only you will be able to figure out, okay, this letter is the most frequently occurring letter or the other one, right? But when you see data like this, in a table like this, all the letters, it is very hard to get or extract information hidden inside it. So what we are going to do is, let's try to make it more meaningful, right? So we are going to make a frequency distribution table. Okay, so this is how you prepare a distribution table. If you can look at the small table here, you see three columns, party, and then you tally it, and then the frequency. You know how to tally, right? How do you do that? You make bundles of fives, right? So how do you do it is, you go along your data, and whenever see you a certain letter, you put a strike in front of that letter. So when you see D, you put a strike here. Then comes R, you put a strike here. Then O. So likewise, you fill this tally table. Whenever you have 5, you make the bundle. So this is a 5, 5 and 3. So the frequency is 13. So there are 13 D letters, 18 R letters, 9 other letters. Altogether, there are 40. Now, which is the highest number? What is the highest number? 18. Now only you can see that R is the most frequently occurrence or the occurring outcome, right? And O is the least. And if you want to do a small calculation, what you can do is you can find the frequency, the relative frequency or the percentage. Okay. So how do you do it? D, there are 13 out of 40. So you make 13 out of 40, which will give you 0.325. So likewise, you can do the frequency, the relative frequency, the value out of the total. Okay, and when you add up all these relative frequencies, they should add up to 1 or 100%. So this is 32.5%, 45%, 22.5%, and added together you'll get 100%. Okay. Now after you prepare a table like this, it is very easy to use a graph. Usually with categorical variables, we stick with two different types of graphs, the pie chart and the bar graph. And I'm sure you are familiar with the pie charts and bar graphs. You widely use them even in spreadsheets. Pie chart is where you have the circle and you divide it into sectors according to the percentages in your category. So if you have 5 categories, your circle will be divided into 5 sectors depending on the percentage. The size of this piece will be depending on the frequency or the percentage for each category. If you use a software, you can find several different types of pie charts in 3D, some pieces coming out with different colors or different patterns. You can draw them very nicely. Then the bar graph is where you have X and Y axis, and according to the percentage or the frequency, you can draw the bars. The height of each bar will represent the number of occurrence or the percentage. It can be either frequency or the relative frequency. You have to name the axis, the whatever the value that you measure in y-axis, and whatever the groups you have in the x-axis. Again, if you want, you can prepare this as a column graph. The same thing the other way around, rotated. Again, with softwares nowadays, you can prepare very nice bar graphs with different colors, even the stacked bar graphs if you have subgroups within each group. Okay, we'll learn these things later in a lab session. But for now, these are the two types of charts you can use with categorical data. Okay, for categorical data, pie charts and bar graphs. So for our example about the political party, here is the pie chart. So you can see the highest are 45%, then comes the Democratic 32.5%, and finally the other one. So if you want, you can use the frequency here. In this one, we have used the percentage, but if you want, you can use the frequency here. Something like this, okay? And you have to put a label or the title to the graph, so it is easily understandable. Now, if you go back to the original data set you had, now this is what you had, right? This is what you had, the D's, R's, and O's. Now, you were not able to say anything about or any summary about these D's and R's and O's if you just look at this small table. But when you have it summarized in a graph, now it is very clear that which party has the highest, which party has the lowest, and what are their relations, right? So you can very easily see it. So that is why we say graphs will make your data more meaningful and easy to understand. Now, for a person who's looking at this graph, will get the information in a few seconds, right? Within just by looking at the graphs, they get the idea. Okay, Republicans are the highest, right? Republicans are the highest. But if you look at that original data without summarizing these R's and O's, it is very hard to figure out any pattern hidden in the data. Now it's the same thing, you can draw it using a bar graph. Here's the bar graph. Again, you can see the height. Republican is the highest, next the Democratic and the others. And you can clearly see the differences, right? Ascending order of the parties and everything. And you can see you have the title here. Right? This is the title of the graph. This is the y-axis, relative frequency. Now in this graph, they have used relative frequency. If you want, you can use the frequency. That is 18, 13, and 9. Still, you will get the same graph. And in the x-axis, you have the party, and you have the 3 parties for each bar. Nicely recorded. So this is how you prepare a complete bar chart. Nowadays, we do not make bar graphs or pie charts using hand, okay, just by scratch. We have a lot of available software to do that, even Excel or the spreadsheet will do that. Any other statistical software, again, you can easily draw these type of graphs. Select colors, whatever the way you want, the font size, the directions, everything can be nicely chosen according to the way you want. Okay, let's do another example. Okay, so I have the blood type of 20 students, or the blood group of 20 students, a sample of 20 students. Okay, these are the blood types I have. First student, second, third one, and so on. I use just A, B, and O, the pluses and minuses I omit. Okay. Okay, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So altogether 20 students. Now this is very similar to the previous example. By looking at this tables, this small collection of letters, it is hard to figure out which blood type is the most occurrence, which has the highest occurrence and which one has the lowest occurrence. You can't easily figure it out. Now, can you all take a piece of paper and prepare the frequency table like we did in the previous one, like this one? You can use the blood type instead of party, tally it, and find the frequency and then the relative frequency. Can you try it for this small data set of 20? Yeah, I'll prepare the table for you. So here's the blood type. Then you can tally it. And you can find the frequency. And then the relative frequency. So we have A, B, and O. Right. Okay, so you can follow me and do it with me. Right. So you have A, B, O, A again, B, AB, O, O, AB, AB, A, O. Now A has 5, B, A, O, 5, A. Okay, so that is how we tally it. I guess this is clear. Do you want to repeat it? Do you want me to repeat the tally? I guess not. Right. So when you have the tally, it is very easy to write down the frequency. 5 plus 3, 8, 4, 3, 5. Altogether we have 20. Okay. Any questions so far? Now let's find the relative frequency. This is 8 out of 20, 4 out of 20, 3 out of 20, and 5 out of 20. Can you all find the relative frequency for me? For A, B, AB, and O. Find the 4 values and tell me. Okay, so what is the relative frequency for A?
40%,
40%, yes. Next one,
20%,
20%, and then
15%,
15% and
25%.
25%. Yes, thank you. Who gave me the answers? What is your name, Putta?
Madam Lakmini.
Lakmini. Okay. So you have 40%, 20%, 15%, 25%. So it is up to you. If you want, you can leave it as the fractions or as percentages. That's okay, right? Either way will be acceptable. Even this division is also okay. Right. Now, can you all try to draw the pie chart and the bar chart for this one? Because it's a small one. You can do it by hand. I'll show you how to use Minitab next time when we are when the labs are available for us. Okay. So we have 4 different types: 40%, 20, 15, and 25. So try to draw it in an approximate scale. I'll try my best. Easiest is the 25% because that's the quarter of it. So that is 25%. Okay. Next, we can try 40%. That is, this is the 50%. So A, and then next is 15 and 20%. Something like this. So the 20% is B and 15% is AB. Okay. So in the same manner, now you can draw the bar chart. If you want, you can use the percentage, or if you want, you can use the frequency. Let's use the frequency because we used the relative frequency in the previous one. Okay. Thank you for everybody who sent me the answers. Okay, so let's do it. A, B, A, B, O. What were the counts? 8, 4, 3, 5. So 8 is the highest. So try to draw approximate scale. 8 for A. Yes, so here's my bar for A. In bar charts, you do not attach the bars. They should be separated, okay? If you attach the bars, that becomes another type of chart that we are going to learn next. The bar charts, the bars are clearly separated, okay? So B is 4. Next we have 3. And O is 5. It's 4. So this is how we draw the bar chart. Okay, so that's not hard. Very easily you can figure it out. Okay, so any question about bar charts and pie charts? So you have to write the correct bar chart for that type or something, the title, the axis and everything. Okay, so this is very easy. Okay. So when you look at the bar chart, you can easily see, okay, A is the highest, AB is the lowest. That is the first thing that you can see. And you can see that the B is about half of A, 8 and 4, right? See, 40 and 20%. B is about half of A. So you can clearly see those type of relationships when you have a graphical summary. Okay. Now let's move on to the graphical summaries that you can use the numerical data. So let's do both discrete and continuous together. Because it's the same thing, slight differences. Okay. Both discrete and continuous. And this one you have, in this example, the number of TV sets in each of 50 randomly selected households. 50 randomly selected households, how many number of TV sets they have. Okay, so usually we have only one TV. Okay, some houses they have two, and in this sample they have even up to 6 TVs. Okay, not in Sri Lanka, some other country. Okay, now in this one you can see now these are numbers. These are numbers and you can't see any fractions. These are very clearly separated whole numbers. Even you can treat this as categories. 0 as one category, 1 another category, 2 another category, and so on. Okay, but these are numbers. So therefore, you have to treat them as discrete numerical data. Now the same thing, the same problem that we see here, it is just a bunch of numbers. You can't clearly see any pattern. Which one is the highest, which one is the lowest? It's very hard to figure it out. And what are the values? Okay, that's also you can't see it clearly by a glance. It will take some time to figure the maximum, minimum and everything. So therefore, for this one also, let's prepare the frequency and the relative frequency. Can you do that? Can you tally this one and prepare the frequency and relative frequency for 50? So I'll give you some time. So we have 0, 1, 2, 3, 4, 5, and 6. So you can tally the number of TV sets. Let me know if I'm making any mistake. See whether I have everything, and if I have made a mistake, let me know. I have all 15. Okay, is this correct?
Madam.
Yes. Tell me if I have made a mistake.
Correct, madam.
Okay. Anybody who got different answers? Right, so I guess that's correct. Now, can you prepare the table, the frequency table? So it is 1, 16, 14, 12, 3, 2, 2. So this will be 1 out of 50, 16 out of 50, 14 out of 50, and so on. So I leave it for you. You can prepare the relative frequencies and put the percentages here, and they should add up to 100%. Okay. So what are the graphical methods that you can use with after you prepare this frequency table? What are the numerical and let's say for discrete and continuous both? Okay. The graphs that we can draw very similar to the bar graph. You can draw the histogram. Histogram is the widely used graph that we use with numerical data, both with discrete and continuous. Depending on the type, discrete or continuous, the way you draw the histogram can be slightly different. I'll show you it. Then you have a very basic graph type called the dot plots. And then you have the stem and leaf plot. And finally, the box plot. In order to draw the box plot, you should know some numerical summaries. Therefore, we are going to look at the box plot after the next section. Okay. So for now, we are going to look at histograms, dot plots, and the stem and leaf diagrams. Okay. Right. So this one is a discrete one. Okay, this example, the number of TV sets, it's a discrete one. So you can clearly see 7, it's like the categorical variables. You don't have any value in between. So you can easily tally it. But what will happen if you have your data like this? Now in this example, these are the days to maturity for 40 short-term investments, right? You know, when you put fixed deposit, they have the maturity, 30 days, 90 days, that is the 3 months, 1 month, 1 year, likewise, right? So these are the days to maturity for some short-term investments. Now, when you look at these numbers, now you cannot prepare or tally like the previous one because these are all different numbers. What is the minimum and what is the maximum? Can anybody find it from this bunch of numbers? The smallest and the largest value of this one? What is the smallest number? Find it for me.
36.
36 is the minimum, yes. Now what is the maximum? The maximum is, yes, Indica, I guess 99 is the maximum. Yes, thank you. So you have the values in between 36 and 99, but you do not have each and every value. You don't see 37, right? You don't see 38, but you have, I guess, 39, right? So you don't see all the values in between, but the minimum is 36 and the maximum is 99. Now in such a situation, you can't tally it like the previous one. What you have to do is you have to group them first, but we call it as the intervals, right? You have to prepare your own intervals and categorize these data. Now this is like continuous data. Okay, this is like continuous data. You have all the values within an interval. Okay, so for this type of data or continuous data also, you can prepare the frequency distribution. Now look at this one. You can see the days to maturity, put them into intervals or the groups. So 30 to 39 the first interval, 40 to 49 next one, 50 to 59 and so on up to 99. So some intervals have a lot of values, some intervals have very few values. Okay. So you know the minimum and the maximum, then you can decide on the intervals. Now this is one way to make the intervals or prepare the intervals in groups of 10s. But if you want, you can prepare groups of 15 or maybe 5s. Okay. So there's no exact rule or theory saying how many intervals that you can have for a given data set or the width of the interval. But depending on the behavior of the data, you can select a better way. Right. So when we draw the graphs using a software, there is an option for you to tell the software how many intervals that you want and how to pick the best number of intervals. Okay. So for now, it is easy when you do it 10 to 10, right? So how do you tally now? So you go over the values one by one, and whenever you come up to a value for a certain interval, you put the tick on the tally. So 70 belongs to this interval. So you put 1 here. Next value is 64. 64 is in the fourth interval. So you tally here. So likewise, you can tally your data into the intervals. So that's also not hard, but you have to concentrate very carefully. Don't miss any number. Do not misclassify. Then you can tally it and easily count the frequency, the relative frequency and everything. So all 40 values. You see that 60 to 69 is the highest, 40 to 49 is the lowest, right? So after you prepare the summary, you can easily see that. And for this, you can draw the histogram. Now again, we have the question, how do you draw the histogram for this one and for the discrete one? So this one also you have a histogram, right? So how do you draw these type of histograms? Okay. You can do it in two ways. If you look at the class limits, okay, so here's the class. So these are called the classes. In the first class, the lower limit is 30, the upper limit is 39. Okay, so the smallest value that could go in a class is called the lower class limit. The largest value that could go in a class is called the upper class limit. So for the first class, lower class limit is 30, upper class limit is 39. So you can find the lower class limit and upper class limit for all these 7 classes. Then the class width is the difference between the lower limit and the lower limit of the next class. Difference between the lower limit of a class and the lower limit of the next higher class. So if you look at the first class, it is 30 and the lower limit of the highest class is 40. So what is the difference? 40 minus 30, 10. Okay, so the class width will be 10 in our case. Then you say the class mark, that is the average of the 2 class limits of the class. So if you have 30, and next 39 and 40. So you have 30 and here comes the 39 because this is continuous. Okay, so soon after you finish 39, 40 begins, right? So the midpoint will be 35. Okay, so that is how you figure it out, right? And the other way is the lower class cut point and the upper class cut point. This is very similar to the previous one. The smallest value that would go in a class, that is the lower class cut point, that is same as the lower class limit. Upper class cut point is the largest value that could go into the next higher class. That will be the lower cut point of the next higher class. Okay, the largest value that would go in the next higher class. Then the class width is the difference between the cut points, and the class midpoint is the average of the two cut points. Now it is like the same thing but written in a different two different ways, because it depends on the way you draw your histogram. If you look at a software, they have these two options, whether you use the midpoints or whether you use the class width. I'll show you it when we do practicals, how to figure it out. Okay. Anyway, using either way, you can draw the histogram. Okay. Okay, let's start with the number of TV sets. Okay. So you can see the histogram drawn for the number of TV sets. The values are from 0 to 6, and you see the frequency and the relative frequency. You see the two graphs. The first one is for the frequency. The next one is for the relative frequency. Either way, you have the same graph. It doesn't matter, right? So it's up to you whether you use frequency or relative frequency. At the end, you get the same pattern. Now, what is the difference between the bar chart and the histogram? See, the bars are attached. If you can remember the bar chart, you have clearly different, the separated bars. You do not touch these graphs, they do not touch. So these are the bar charts. When it comes to histograms, because soon after you finish number 1, then start the values for the next interval, right? So therefore, you have the attached bars. Now here, you see 0, the tick is for the midpoint, but the 0 is for this whole set. Okay, 0 is the midpoint. For 0, there's only 1 for the frequency. Okay, then the 1, this is the bar for the 1. Okay, this is the bar for the 2, and so on. You can see the histogram. Okay, so this is how you draw the histogram for discrete cases. Okay, so if you draw the histogram 0, 1, 2, likewise, it is not that much clear for the discrete cases. That is why we use the midpoint for the discrete cases. So this is the best way to draw a histogram for discrete cases rather than using 0, 1, 2, and 3. So it will make you confusions. So this is how you draw the discrete cases. But when it comes to the continuous data, now you have the intervals. So your bars will be that whatever the interval, 30 to 40. Now you don't put a tick in between, but you use the whole interval. Okay, I have a question. Madam couldn't understand that drawing 2 lines at the front. Okay, so this one, right? I think you are talking about this one. Okay, so this is what we use, these 2 lines to show that this distance is not in scale. Okay, but this one you can use it because you can use 0 straight away here. Then it will make your graph too crowded. So you go for a small gap. Okay, but this gap does not give you any value here. Okay, it's out of the what do you call? It's not in the correct what do you call it? The size. Okay, the length that you see in between here and here, it is not the gap as you see in 0 and 1. There's no information about this gap. Okay, it's just a gap to make your graph nice. Okay, so that is why we use it. Now you can see it here also. Now, okay, so in this one, we'll do the same 2 lines here. Now, if you look at this continuous data, your line start at 30. From 0 to 30, there's nothing. So there's a huge gap in between 0 to 30, right? And it starts from 30 and goes up to 99 or 100, okay? And you draw the bars according to the frequency or the relative frequency. Okay, whatever the way, okay for you, you can use it. Either way, you get the same graph. Now, if you want, you can draw it like this. Rather than leaving space for all these 0 to 10, 10 to 20, 20 to 30, because there's nothing, what you can do is, you can draw these 2 lines and start 30 here. 30, 40, 50, 60, and so on. So what you have in between 0 and 30, it's out of scale. Okay, it's not showing you the exact scale. This is the exact scale. But if you leave the exact scale, you are losing a lot of space. So rather than doing it, you can straight away start the graph and showing these 2 lines. By indicating these 2 lines, you say for the audience that the gap between 0 and 30 is not in exact scale, but it is just a gap. Is that clear to you, Sashini?
Yes, madam.
Okay.
Thank you.
Because sometimes you may end up with data, starting from say 75 up to 130 or something. So if you are going to draw the histogram from 0 to 75, there's nothing, right? So your graph is somewhere here. All this space, it's useless. So what you can do is, rather than doing that, you start it straight away at 70, 80, 90, and so on. So in between 0 and 70, this space, it's out of scale. It's just a gap. So that is how you draw the histograms, okay? So that is the indicating out of scale, right? Okay, so is it clear the difference between continuous and discrete data? So for the continuous data, you use the class cut points 30 to 40 as the interval, but with the discrete, you use the midpoint. Okay, so that is the difference between the histograms for discrete and continuous. Okay. So as I mentioned, this is not the only way to draw the histogram. For this one, we have used the class with 10 with 7 classes. If someone thinks that, okay, I'm going to use the class with 35, with the class with 15, then they can go for 30 to 34. 30 to 44, 45 to 60, 59, 60 to 74, 75 to, and so on. So that is the class width of 15. That is also possible. So you'll end up with a different tally, different frequency, but the original shape will be very similar. Right? The shape will be very similar. Okay. So this is not the only answer that you can, or this is not the only way to draw the histogram for this data. Okay, if you use different class widths, you'll end up with a different histogram, but the pattern will be very close. Okay. Right. So that is about histograms, and I'll do a practical session and show you some other different things that you can do with histograms, how to change the colors, the shapes, how to label them, X and Y axis. If you have different groups, how to do the stacked histograms and so on. So I'll show it when we do practicals. Okay. So that's the first type, the histogram. Next comes the dot plot, which is a very, very basic type of graph. You can clearly see this example. These are the prices in dollars of 16 DVD players. So there are 16 values in dollars. Again, these are a bunch of numbers. You can't see any pattern. But you can find the minimum and the maximum and draw the number line and then put a small dot whenever you see the corresponding number. If you look at this data set, you can see the smallest value is 197, right? So this is the minimum. Then the maximum is 224. Here's the max. So you can draw the number line values closer to the minimum and the maximum. Okay. Even you can stop from here. You can stop from here. It's up to you. And then whenever you see a value, you put a small dot. Right. So the first one is 210. So here's 210. You put the dot. Then 219. Put the dot. 214. That's 214. Here's the dot. Then 197. Here's the dot. And likewise. So whenever you have a repeated value, you put the dot in front of it or the top of it. So you have 210 again. So you put the dot. 119, it appears 3 times. See? So you have 3 dots stacked on top of it. Is that clear? So this is a very basic type of graph. You can very easily draw it. This is not good if you have a large number of values in your sample. Drawing a dot plot by hand will take a lot of time, but using a software it will be easy. The thing is, you can easily see the distribution of the dots. You can see that 119 and 219 appears most of the time, and in between 200 and 200 and 7, there are no values at all, right? So likewise, you can easily see the pattern. Okay. Now, can you draw the dot plot for the days of maturity? So you already have the tally for the days of maturity for 40 values. Okay. So you can try this one. Draw the dot plot for the days of maturity. You already know the minimum and the maximum. Yes, you have a question. Can you use the dot plot using a software if the range of values is? Yes, of course. You can always use the software to draw the dot plot. Very easily, it will give you the answer. So no need at all to draw it by your hand. Nowadays, you can easily draw it using a software. So I'm just showing you how to draw it here. Okay. So minimum 36 and maximum 99. So you can do it in tens. Try to draw it in scale. So I'm not going to fill everything. I'll just show you. Okay. You can put a tick. And so on. So here's 70. 64 will be somewhere here. 99 will be somewhere here. 55 here. 64 again. 89 somewhere over here. 87 and so on. You can draw the dot plot. Okay. So I'm not going to do it the whole thing, but you can try it. Okay. Next comes the stem and leaf plot. So this is also a very nice way of representing your data. Very similar to the histogram, but you use the actual numbers here in your bars. Okay. When we say a stem and leaf diagram, you can see that there are 2 parts. the stem and the leaf. Okay. So the same data set, the days to maturity, this is how you draw the stem and leaf diagram. You divide your paper into two parts with a straight line, and your left hand side you put the stems, the right hand side you put the leaves. Okay. Now in this data you see only two digits, 70, 7 and 0, 64, 6 and 4. So these digits, you know the placement, these are the ones, these are the tens, right? You know that. So when you look at a number according to the number of digits, you know how to write the placement. Say for example, if you write a number like this, how do you write the placement? This is the ones, these are the tens, you have the hundreds, this is the thousands. This is the 1 over tens, this is the 1 over hundreds, the decimals. Okay. So by looking at your data, you have to figure out what are the digits you are going to put into stem, what are the digits you are going to put into leaves. In this example, you have only two, so you can split it, the tens into the stem and the ones into the leaves. Okay. So you know that the minimum is 36 and the maximum is 99, which means you have values 30s, 40s, 50s, 60s up to 90s. So you write these stems here, 3, 4, 5, 6, 7, 8 and 9. So your stems are 3, 4, 5, 6, 7, 8 and 9. The next what you do is you go along your data set, and for whatever the value you get, you look at the stem and write the leaf in front of it. So when it says 70, your stem is 7. So here's 7, you put the 0 here. So that is your leaf. Next is 64. 6 is the stem. Okay. Okay, so it's going downwards. So next is the 62. So here's 6 and you put 2. Okay. Next is 75. Here's 7 and here's 5. When you fill the leaves, you are not going to put any commas, dots or nothing. Simply leave a space. Okay, just a space. Just a space. So you have zeros, fives, ones and so on. Okay. So likewise, you fill all the leaves for your stems. But the final product, you should order your leaves in ascending order. So for the stem 3, you have 8, 6, 9 in ascending order. It will be 6, 8 and 9. For 4, you have only one leaf, that is 7. For 5, there are 8 leaves. So you do it in ascending order, 0, 1, another 1, 3, 5, another 5, 6 and 7. So likewise, you prepare the leaves in ascending order. Is that clear to all of you? So here's your stem and leaf plot for the maturity data. This is not complete. You have to give the the key. The key is how to read it. Now, if you do not know the original data, anybody who's going to see this stem and leaf, they do not know how to read it. Is it 36 or 3.6? Okay, so you do not know. So you have to give the key. This is how you write the key. Your stem is tens. Your leaves are ones. So you have to give this key beside your stem and leaf diagram. Okay, so here's the key for this data. So you look at the key, it says stem is tens, leaf is ones. So you know this is 30, this is 36. You know this is 36. This is 47, 50 and so on. Okay. So you have to give the key along with your stem and leaf diagram. So anybody who's going to read this, they know our stems are 30s. So this is 36. Okay. So this is how we draw the stem and leaf plot. Again, if you have a large number of observations, you can't do it by hand. Anyway, we don't do it by hand nowadays. You can ask a software to draw the stem and leaf diagram for you, and it will nicely prepare the diagram for you and some other information along with it. And again, I'll show you how to interpret a diagram using a software. Okay. Any question about the stem and leaf diagrams? So the main things you have to understand is, by looking at the data, figure out the stems and leaves. It can be 2 digits, it can be 3 digits, it can be many with decimal places. But you have to figure out what are the digits you put to stems, what are the digits you put into leaves. And after you prepare the diagram, make sure the leaves are in ascending order and you give this key. Otherwise, you don't know how to read it. So yes, this is the question I was expecting. Can we have 2 digits in the stem side? Exactly, you can. For the leaves, you can have only 1, but for the stems, you can have more than 1 digit. So let's do an example. Okay, so here's the answer for your question. Cholesterol level for 20 high level patients. So let's try to draw the stem and leaf plot for this data set. Can you hear me clearly? Because it's heavily raining here and maybe there's some distortion in the sound. Can you hear me clearly? Do you get any noises that's disturbing? I guess it's okay, right? So there are 20 observations. Now, what is the minimum and what is the maximum? Figure out the minimum and the maximum. Okay, tell me what is the minimum. Yes, the minimum is?
Minimum is 199.
199 is the minimum. Yes, thank you. And the maximum? What is the maximum?
$221.
221. Yes, thank you. I got several answers. Thank you for those who answer me. So this is the min and the max. So what is the range? 199 to 221. So let's use the minimum. It has 3 digits. You have the ones, you have the tens, you have the hundreds. If you use, and then you have the maximum, which is 221. Again, the ones, tens, and hundreds. So, what do you think? If you use your stem to be only 100, how many stem values are there? Only 2. So only 2, and do you think it's going to give you a nice graph? Just 2 lines, right? You won't get much information from that. But if you use both hundreds and tens into your stem, you'll end up with 19, 20, 21, and 22, 4 digits, right? So that will be more meaningful. Therefore, when you prepare the stem and leaf diagram, for this one, you can use both hundreds and the tens digit for your stem. Okay, so let's do that. Here's the stem. Here are my leaves. 19, 20, 21, 22. Okay, so the key is stem will be hundreds and tens. If you put hundreds only, that is also okay, because so your leaf will be ones. Okay, so this is the key. Okay, let's fill it. We have 199, I guess that is the only one. For 20, you have a lot of values. Okay. So try to find the leaves for 20 and give me them in ascending order, please. All the leaves for 20 in ascending order. And then all the values for 21 in ascending order. For 22, there's only one. So I'll do 21 for you, but you can try 20 and give me the answers. 21 will be 4 zeros, 2, 3, 4, 5, 7, 8, 8. A lot of leaves for stem 21. Okay, so what are the values for 20? What are the leaves for 20? Here I have one answer, 0, 2, 3, 7, 8, 8, 9. Thank you, Manisha. Anybody else? 0, 2, 3, 7, 8, 8, 9. Yes. So I guess you know how to do it now. I'll write it here. 0, 2, 3, 7. Thank you for answers. 9. Right. Now what do you see here? For 19 and 22, just one. For 20, a lot of values. For 21, another set of a lengthy set of numbers, right? Now, do you think there will be another better way to do this stem and leaf diagram? What you can do is you can use repeated stems. Repeated stems. If you see lot of stems having lengthy leaves, right? Large number of leaves for a single stem, what you can do is you can repeat them. You can split your stem values into 2 or even 3. The widely used one is you split it into 2, which means 0 to 4, the first one, 5 to 9, the next one. Okay? And the key will remain same. So when you see this key stem is hundreds and tens, you know this is 199. That is how you read it. Oh, this is 202. You know how to read it because that key is given, right? So this is how you do the stem, the repeated stems. You are going to repeat every stem. Now in this one, we are going to do it 2 times. 19 twice, 20 twice, 21 twice, 20, sorry. 21 twice, 22 twice. So the first 19 is for 190 up to 194. The next is for 195 up to 199. Okay, so I'll write it here. You don't have to write it, but just to show you, this is 190 up to 194. The next repeated one is from 195 up to 199. Next is from 200 up to 204. Repeating 205 up to 209. Okay, so this is how you do the repeat. You don't have to write it. This is just to show you. Okay, now let's fill it. You have 199. It should be here. So the first one, it's empty. So when you have empty stem, you don't remove it. You leave it there. And if you are repeating a certain stem, you have to repeat all the others. If it is repeating twice, you have to repeat every stem twice. If you are repeating 3 times, you have to repeat every stem 3 times. There can be stems without leaves, but still you have to leave them. Okay, you have to leave them as it is. Okay, then comes 20, the first half, 0, 2, 3. Then comes 7, 8, 8 and 9. 21, first half, 2, 3, 4. Next half, 5, 7, 8, 8. 22, 1. There's nothing for 22 up to that, but you leave it there. Okay. Now, what do you think? It's better than the previous one, right? See, it's a nice symmetric one. Okay. So you can see a pattern very nicely when you use a repeated stem. You do that whenever you have a large number of leaves for a single stem. Okay, whenever you have large number of leaves for a single stem compared to others, you do a repeated stem. So here's my stem. Here are the leaves. And still you have to write the key. Give the key, stem is this, and the leaf is this. So give the hundreds and tens, ones, and so on. Okay. Right. Any question so far about the stem and leaf diagram? Now, what if you have, this is something extra, but there is an example at the end, but for now I'll give you another example. What if you have a data set like this? 7.2, 3.5, 1.0, 2.7, and something like this, with the minimum 1 and the maximum, say, 8. What is the best way to choose the stem and the leaf? Any answers? How do you choose the stem and the leaf? Yes, what will be the stem and what will be the leaves? Yes, you can use stems as ones and the leaves as 1/10. Yes, exactly. This is how you should do it. Your stem will be ones and leaves will be 0.1, so 1/10. So you write this as 1, 0, and there will be up to 8. So 3.5, you write it like this. You don't put the decimal point. Okay, you never include the decimal point because it's given in the key. In the key you say stem is ones, leaves are 1/10. So whoever read this, they know the leaves are decimal. So they will read it as 3.4. You do not have to put a decimal point in your stem and leaf diagram. You just put the number according to the key. Anybody who's going to read it, they know it is going to be 7.2, 3.4, not 72 or 34. Okay, is that clear? Even the 2 digits you can do. If you have values like 25.7, 29.8 and so on, you can use. Your stem will be tens and ones. Your leaves will be 1/10. Okay, even 1/100. If you are going for second decimal place, that is also possible, right? Okay, so that is the stem and leaf diagram. So we learned about histograms, dot plots, and stem and leaf diagrams. So what are the differences between these graphs? The histogram, it is very nice to get an idea about the shape of your data. Even if you have large number of observations, histogram will work nicely. The dot plot is a very basic type. It is good if you have small number of observations. The stem and leaf also will give you the shape of the distribution, very similar to the histogram. And it will give you more information because it shows you the values. The histogram will show you only the height of a bar according to the frequency or the relative frequency. For the stem and leaf plot, you see exact numbers and some more information. And we'll discuss those things when we do exact practicals. Okay. So which means you should know what are the distribution shapes that you will end up with. Okay. Either you draw a histogram or a dot plot or a stem and leaf plot, you can identify several shapes in your data set. Okay, we call it the distribution of the data. What does that mean? A distribution of a data set is a table, graph, or formula that provides the values of the observation and how often they occur. So distribution will tell you how each and every value is occurring within that given interval. Some values occur many, many times. Some values occur very small number of times. That is the frequency, right? The frequency is how many times, how often. Okay? How often, how many times. So you already know if you have a value that occurs the largest number of times, it has a name which is called the mode. Okay? So we are going to learn those numerical summaries in the next section. Okay? So those things can be described using the distribution of your data set. Usually, when you draw a histogram or a dot plot or a stem and leaf diagram, you can easily figure out the shape of the distribution of the data. Okay, the shape of the distribution. Especially a histogram will give you a nice graphical view of the shape of your observations. Okay, so here are some common distribution shapes. This nice bell shape. Okay, nice bell shape. It is symmetric about the highest one, to the left and to the right, evenly distributed. So we call it the bell shape. You may end up with the triangular or uniform. Okay, so that means in your histogram you have all the values the same value, same number. That is the uniform. You may have the reverse J shape, the J shape. The skewness, this is called the right skewness, this is called the left skewness. You define the side of the skewness got the longer tail. Okay, so the longer tail is the right tail. Can you see that? These are the tails. This is the left tail, this is the right tail. The right tail is the longer tail, so it is right skewed. Or you may say positively skewed. The skewness is positive. This is the reverse of it, left skewed. That means this is the left tail, this is the right tail. The left tail is larger or the longer. Right tail is not that long. So the left tail is the longer tail, therefore this is left skewed. Or you can say negatively skewed. Or sometimes we say skewed to the left. Okay? Skewed to the right. Positively skewed, negatively skewed. Okay? Sometimes you may get several peaks. Okay? One peak is, we call it unimodal. One peak, one clearly visible peak. Okay? Clearly visible. If you think about all the peaks, then you'll be in trouble. This is clearly visible, two clearly visible peaks. Bimodal, that means most frequently occurring values, we have two of them. Here, this is multimodal. Many peaks are there, three or more, right? Multimodal. So either you'll end up with unimodal, bimodal, multimodal. They can be symmetric or they can be skewed. If it is skewed, it can be right skewed or left skewed. Sometimes uniform or J-shape. J-shape means if it is the reverse J-shape, you have a right tail but no left tail at all. J-shape is you have a longer left tail but right tail is no right tail at all. Okay. So those are the shapes that you can get. So for example, what about this one? What do you see here? Is it unimodal or bimodal? You can see that this is unimodal. Is it symmetric? Do you think that it is symmetric? It is not symmetric, right? It is not symmetric, it's skewed. It is skewed to the right. See, the right tail is longer than the left tail. So this is positively skewed or right skewed or skewed to the right. You can use either way, positively skewed or negative, right skewed or skewed to the right. You can use either way of explaining it. Okay. But if you have a graph like this, can you explain this distribution? Can you explain this distribution? Shape. How do you explain this one? So you can say two things. You can say things about the number of peaks and then the symmetry. Okay. So how do you explain this one? The distribution of the data. You can see clearly two visible peaks. So this is bimodal. And see, it is like this, right? So the left tail is longer than the right tail. So this is a negatively skewed. Bimodal and left skewed. Yes, this is bimodal and left skewed. Okay. Now there's another tricky thing about this, the shape of the distributions. Say for example, after you draw the histogram, you got something like this. Your histogram, you got something like this. So this is slightly symmetric but slightly skewed. Now how do you explain this one? So that's why I said the way you justify. One student will explain this as slightly symmetric. This is not exactly symmetric because there's a deviation. So you may say slightly symmetric. This is correct. Another student may say slightly positively skewed. That is also correct. That is also correct. So these are the two different ways. If sometimes you may say slightly skewed, some person will say slightly symmetric. So it's the same thing given in two different ways, explained in two different ways. So that's okay. Okay, slightly symmetric, slightly skewed, that's fine. Okay. Any questions so far? So here's an example for you. You have the daily temperature values for the month of January, but this contains only 30 values, not 31. Okay, only 30 observations. Okay, so as an assignment, what you have to do is, this is only 30 observations, so you can easily prepare the dot plot, the stem and leaf plot, and also a histogram. Try to use your own scaling, right? One way of scaling or intervals, and try to come up with the histogram, and then you can draw the stem and leaf plot and the dot plot very easily. Okay. Since this is continuous data, you can clearly see with the fractions, this is continuous data. When you tally, you have to come up with the intervals first and then tally it. Okay. So I'll leave preparing. So I have to prepare the distribution table, choosing your own intervals, and then draw the histogram. Okay. But now let's try to find the minimum and the maximum, and let's try to draw the stem and leaf plot. Okay, let's try to draw the stem and leaf plot for this data set. Try to find the minimum and the maximum. Okay, we have about 15 minutes. So can you try it? Find the min and the max. Figure out the stem key, the stem values, stem digits, and the leaf digits, and then draw the stem and leaf diagram. And then you can interpret about it based on the shape. Okay. So the first thing you have to do is find the minimum. Okay, so find the minimum and the maximum and let me know. And then figure out the stems and leaves. And we'll see how we can draw the stem and leaf plot. Minimum is 20.0. Yes. Max is 25.1. Okay. So thanks, Lahiru. Minimum is 20.0. Here's the minimum. Max is 25.1. Okay, thank you again for the answers. Okay, so what are the stems and the leaves? You can go up to 20 to 25. So your stems will be tenths and ones. The leaves will be 1 over tenths, right? So you have 20, 21, 22, 23, 24, and 25. .0 1. For 21, there are 2. So 20 we did. We have 20.5. Then 21, we have 21.5. And 21.9 3 times. So 0.25. So you have 20.2 also. Oh, yeah. So you have 2 and 5. Okay. Next. So this for 20, 0, 2, and 5. Okay. So I have 21. Now try 22 also. This 22, 22.1, another 22.1, 22, oh, we have 22.0, so 0 is there. Another 22.0, another 20, hold on, yes, another 22.0, 22.1, three 22.1s, okay. Then we have 22.5, and then we have 22.6, and 7. 0, 0, 0, 1, 1, 1, 5, 6, 6, 7. Okay, yeah, thank you. So what about 23? 3.0. 23.1. Another 23.0. 23.1. Another 23.1. 23.2. 23.3. And 23.5. 6. 0, 0, 1, 1, 2, 3, 5, 6, and 7. Yes, 23 point. So, okay. Right, next is 24. We have 24.8, 24.1, and 24.9. 24.8, 9, 1. Finally, 35.1. Okay, so you have 10 values here. Okay. So if you wrote down your numbers in nice stacking way, everything on top of the other one, not like I have written it. If you draw the shape of this one, it will be like this, right? We have 3 values, 4 values, 10 values here, and 9 values, 3 values, 1 value. right? So what do you think about this one? You can't see any skewness. I mean, both sides is there. It's not symmetric either, so you may say this is slightly symmetric. There are 10 values here, 9 values here. So this is a unimodal. Is this clear to all of you? How do you get the distribution shape? Okay. So try to draw if you draw the dot plot, it will also look like this one, right? 10, so this is actually the dot plot I had drawn, right? The dot plot. Now, if you want, you can draw the repeated stems, but there will be a lot of spaces. So I think for this one, repeated stems is not necessary because you can see a nice shape. Okay. So any question about this one? So for this data, you have to draw the histogram. Okay, so that is your assignment. Draw the histogram for your data. Pick the intervals. The length you can decide, the length of these intervals and the number of intervals. According to that, it's good to have the equal width for all the classes and then try to draw the histogram. Okay, any questions so far? And that's what I have planned to do for today, the graphical summaries. We talked about the graphical summaries for both categorical and quantitative type of data. You cannot use pie charts or bar charts with the numerical data. You can clearly see that. You can't use dot plots or stem and leaf with the categorical data. Okay, so you see the difference. So you have a separate set of graphs to represent categorical data. You have separate set of graphs to represent numerical data. In either way, when you represent your data using a graph, it will give you information quickly. Within a glance, you can get or you can extract information of your data by looking at the picture. Okay, so that is the whole idea about graphical summary or the graphical representation, to give the audience the idea about your data and the distribution quickly. Okay, right, so that is the first section of chapter 1. Right, do you have any question before we finish the lesson? No questions? Okay. So the next time we are going to do the second section of chapter 2, organizing data, that will be numerical summaries. So I'm going to show you how to represent or how to extract information for quantitative data using numerical summary. Even for categorical data, we have few numerical summaries that we can use. So we'll learn about the numerical summaries in our next lesson. So as usual, these slides will be available as soon as the LMS is up for this course, because we had to postpone it. I think the time frame is gone, therefore this course is not appearing in LMS now. I have requested it. So as soon as it is there, I will upload again. I hope the previous lecture notes are there. So I will upload this slide, okay, and the assignment. Yes. Any other questions? Okay, then let's stop for today. Go over these notes again after I upload it and try to understand it again. And if you have any other questions, you can email me or you can ask before we start the next lesson, the next class.